Hello guys, welcome to my YouTube channel. I'm Mas Jafrani and today I'm starting a playlist for Docker. So today I'm going to start with Docker, and today we are going to discuss about what is hypervisor and why was it used before. Such like I will give a short introduction like what is hypervisor, and then we will understand the concept of containers, and then understand like why do we use Docker, right? Because Docker is used for containers, right? As we already know. So why do we use Docker, and like what are the basic commands to run the container, create image, and how to pull the images from Docker Hub. So we are going to understand that in this video. All right, so basically to understand Docker, let's first understand like what is hypervisor, right? Then we will move on to containers. So first, let's say if I have a software house, right? And I have a development team and a testing team, right? And let's say if I want to I made an application as a developer, and now I want the application to be tested, right? Now when I transferred the application or shipped the application to the tester, now tester is saying that your application is not working, and since I don't know, maybe you didn't develop the application correctly, right? So the problem was basically that my application has lots of dependencies that are attached to my application. My operating system also has some underlying resources which are attached to the operating to my application. So that's why the tester doesn't has the same features or same dependencies version, same dependencies, underlying features, or the same operating system even. So that's why the tester cannot run my application, right? I built it correctly, but the tester cannot run it because the operating system is different. The dependencies are not installed on his system, the tester system. So what I can do is I can transfer the whole operating system to the tester, my whole operating system to the tester, but of course it will be a bulky job, right? So here then came the concept of hypervisor, right? So what hypervisor is? So hypervisor is basically a management tool, right? It manages the virtual machines. Hypervisor is basically a software which manages the virtual machines, right? So let's say in let's say I have a host operating system, right? On top of that I installed a hypervisor on that hypervisor I will have different virtual machines running, right? On each virtual machine I will run different operating systems, different guest operating systems, right? So for that I will assign memory to each virtual machine, right? So that they can run independently, right? So my each application would, like for example I'm working on 4 applications, so I made 4 virtual machines on the hypervisor, and each virtual machine is running on different guest operating systems, right? So let's say now, since there are hypervisors, so I what I did was I created a virtual machine on the hypervisor. I guessed sorry, a virtual machine. Then on the virtual machine I installed a guest operating system such as Windows, and I made an application now. And now what I did was I packaged the application in an image, the whole guest operating system I packaged it in an image, and I transferred it to the testing team, right? To the testing team. Now the testing team will just run the application. It will just create a container, and then they can just run the application. And now they will not face any problems such as of dependency of underlying resources or having a different operating system, right? But the problem is, let's say if I have 4 to 5 applications, so we would, or let's say we have multiple applications, right? So we would need to create multiple virtual machines, right? Which would be really, which would consume a lot of memory, right? Because let's say if a system is of let's say maybe 20 GB, right? Just an example. And if I have 6 applications, right? And each VM needs to be assigned a minimum of 4 GB, right? So I'm assigning like 4 GB to each VM. And now my systems of my host operating systems memory is being consumed completely, and I don't have much space left to create further virtual machines, right? If I have more applications, let's suppose. And also one more problem with hypervisor was, let's say if I assigned a memory to the virtual machine, And even if that virtual machine doesn't requires that much hard drive, that much core, that much RAM, but I've still assigned a memory to it, but it doesn't require that much memory, right? So it is over allocation of resources, right? So we are wasting our memory, we are wasting our resources, right? And we cannot even stop the virtual machines if we are not using it. The memory is allocated, it's permanent now. So that was the problem with hypervisors. Yes, so then came the concept of containers. So containers are basically lightweight, right? So hypervisor was requiring a lot of resources. So over allocation of resources was happening. It was requiring a lot of memory, right? And also, if we wanted to run multiple applications, we couldn't do it because the system has some certain amount of memory that it can allocate, right? So it cannot create further virtual machines. Of course, the system doesn't has much space left, right? So that's why the containers came into being, and containers are basically lightweight. It is basically, the actual term is basically Linux containers, right? But we call them as just containers. Containers are basically lightweight, and they don't need different operating systems to run on, right? They don't need a separate operating system. So consider like this, like you have a hardware, you have a host operating system, and instead of the hypervisor, you have Docker, which will manage the containers. So you have hardware, host operating system, Docker, and then you will have multiple containers running on the Docker, right? So the containers won't need different operating systems, right? A separate operating system. So they will run on the host operating system, right? They will use the resources of host operating system. Like unlike hypervisors, they won't require a different operating system to run on. So that's why they are lightweight, and they don't require a lot of memory as compared to virtual machines. So that's why they are lightweight. And in containers, basically what you will do is you will now pack the application in the container, and then create the image of the container, and then ship it to the testing team now, right? So so what the testing team will do is, now from the image that you transferred to the or ship to the testing team, the testing team will create instances of the image that you sent. So instances is basically containers, right? So they will create containers from the image that you sent. So assume like there's a class, right? So in the class you create multiple objects, right? So class is like an image, and the instances or the objects that you create in the class are like containers. So image is in class, and from the image you create containers are called are objects or instances, right? So let's understand what Docker is. So basically Docker is an ecosystem which manages all the containers. Docker basically eases the process of development. How? That it gives us a ecosystem or a platform on which developers can run and build applications and package them inside lightweight and portable containers, and then build images of them, and then ship it to the testing team or deploy them also maybe to the servers. So let's see the basic Docker commands, and let's see how do we use the Docker Hub, and how we run, stop, delete, uh, create containers, right, using Docker. All right, so I've moved to my screen. So let's understand how we run the Docker commands and how do we create containers and stuff. So first, let's go to Docker Hub, right, and understand what Docker Hub is. So basically, Docker Hub is it's a public platform, you can say that, in which you can pack the images and make it available publicly, right? So you create containers, and from containers you create images, and the images you can push them to the Docker Hub, which can be further used by other people, right? So it's available publicly, but it also has some private registries which can be managed by a specific company which doesn't wants to expose their images to the public. So they can create their private registries also, right? All right, so we have this is the Docker Hub, right? So in Docker Hub we have multiple images available. As you can see that there are TensorFlow, PyTorch, so many images available. And as I mentioned that you can push your images to the Docker Hub, which can be available publicly or to your private association or the private uh, organization that you want to collaborate within the team. So you will just do it in the private registry so that it's available within your team members only. And secondly, you can also pull the images from here. So as you can see that these images are available publicly, right? That's why we can view them. So you can pull the images such as Redis, TensorFlow, and all these, and you can use them in your local machine, right? So to run Docker, basically to run containers, you need Docker, as we discussed before. So we would need to download Docker desktop, because you know that the containers work on are based on Linux, right? So that's why we need Docker desktop, s- so that we could create the containers and work with them. So hmm. All right, so this is Docker desktop. We can go to the Docker desktop and we can download it. From here we can download the Docker desktop. So over here you can see that you can download it for Mac, Windows, or Linux. I will also include these two links in the description so you can check them out and download from the links directly. So you can just download it. You can click on any of those and it will just download, and then you can just open the application. So the Docker then will be running on will be installed on your system. So you can either run the Docker from its graphical user interface, its application, or you can use it via the terminal, right? So I have the Docker desktop already opened. So the Docker desktop would look like this. The GUI would look like this. So here you will have all the containers. So I have all the containers available here. These are all stopped. So these are not active, but these are the containers that I've created previously. And then here I have all the images, right? So I have over here all the images, right? So which I created before. So these are the two things. There are other things also, other stuff also, but these are the two things that are of main concern for us right now. So as soon as you download the Docker desktop application, you will see the GUI like this. All right, so let's pull an image from the Docker Hub, and then we will work on that first to understand the basic commands. So let's write nginx over here, click on enter, and you will see all the nginx images available, but I think this one is the official one. Yes. So let's click this, and you can see all the tags that are available for the nginx links that we can use to pull the image for nginx. So let's say I want to pull this the image with this tag 1.25.5, right? So I will open my terminal. Usually I prefer working with the terminal, but you can also work with the graphical user interface, right, to create the containers and stuff. But I will use the terminal. And all right, so to pull the image from the Docker Hub, we will write the command docker pull the image name, which is nginx, and the tag that we are pulling, right? The version of the nginx that we are pulling, and that version is 1.25.5, right? If we just write nginx, so it will by default pull the latest version of the image of nginx, right? So that's why I don't want to use the latest. I just want to use the version or the tag which is 1.25.5. All right, so if we press enter, now we can see that the image has been pulled from the Docker Hub, the image of nginx 1.25.5 with the tag 1.25.5. And to verify it if the image has been pulled or not, we can write the command docker images and can execute it, and we can see that the nginx image has been pulled with the tag this, and the image id is this, right? And we can also verify it from the Docker desktop, that you can see in the images we have the nginx image with the tag created, right? So we have the image available locally now. So what it did was, when we executed the docker pull command, so it went to the Docker Hub and it downloaded the image and made it available locally for us, right? So it downloaded the image from the Docker Hub and it made it available for us locally. So we have it available locally over here, as you can see in the Docker desktop and also in the terminal. All right, so now let's see how we can run the container out of this image. So just having the image is of no purpose, of course. So we will create a container from this image and run this container, right? So for that, to create the container and to run the container, we write the command docker run, and the image name is nginx, and then the tag we use was 1.25.5, right? So docker run nginx 1.25.5. all right, so the name and the tag we used. All right, so as you can see that the logs are printed after we executed the command, so that means the container is up and running, right? So we can also verify it because from by opening another window for the terminal. So so I have a new terminal window open, so I can execute the command docker ps, which will show us all the containers that are up and running currently. So we can see that our container is running, right, as it displays the image name and the tag, right? And it is running on port 80. All right, so now let's close this. And all right, so this in this terminal, the logs are basically, they are blocking our view in this terminal, right? So we can execute the command control plus c. After executing the command control plus c, you can see that the container has stopped. So we can first of all clear it. All right, so now we can verify that if the container is running or not by running the command or executing the command docker ps again, right? So after we execute the command docker ps, it will show, you can see that okay, no container is running right now. All right, so we want the container to be running in this same terminal without printing the logs, right? So we will use a term called, or a command called -d, right? So this means that it will run in a detached mode, right? So the logs won't be printed. So you can execute the command docker run um, /d -d or -d, docker run -d, and the name of the image and the tag 1.25.5. all right, so it will now run the container in the detached mode. All right, so it printed the id. So now it is up and running. We can verify that by executing the command docker ps. So docker ps, again, it will always show us all the containers that are currently up and running. So you can see that it is now up and running, right? The image and the tag. All right, so rather than writing the docker pull command and then the docker run command to create the container, we can just write a single command, just the docker run, uh, to pull the image from the docker hub and also to run the container. So we can just use a single command rather than using both the commands, right? So that's why I used a different tag right now. I used the tag latest. As you can see in my terminal, that I use the tag docker run detach mode image with the tag latest, and what it did was like it pulled it automatically now, right? So we I didn't write docker pull nginx latest. I just wrote a single command docker run detach mode image and the tag. So what it did was it first of all check if the image is available locally. If it is available locally, so it will use my image from my locally, right? Otherwise it will pull the image from the docker hub automatically. So the my image with the tag latest, the image nginx image with the tag latest is not available locally. So it printed a message that it is unable to find the image. So it will pull it from the docker hub automatically, right? After pulling it from the docker hub, it will create the container and will run the container automatically. So after it pulled the image, you can see I ran the command docker images, and you can see that the nginx is available locally now with the tag latest, right? And after I executed the command docker ps, I can see that the nginx image with the tag latest is also running right now, right? So both of my containers are up and running right now, and I can also verify these from my docker desktop GUI. So you can see that the images are available, both of the images are there, 1.25.5 and the tag latest, and also the containers are, both of the containers are up and running, right? You can see that it says basically this is the the container name, right? It is assigned by default because we didn't assign any name. So we will also learn it in the coming few minutes. So look, this image is also running, and this container, this is also running. All right, you can see that it's written running. Right, so we can, I will expand this window. So after, okay, so let's see, we have two containers up and running, right? So let's first stop this container, because now we will learn about how to run the docker containers on our local host, right? So for that we need to expose the ports to the local host, right? So we will do the port binding. So first let's stop both the containers. So for that we use the command docker stop, and we use the container ID. So you can see that this is container ID. So let's stop the first container. So you write docker stop and then the use the container ID, execute it, and let's stop both of them. So let's write, so docker stop. So both the containers are stopped. So after we execute docker ps, so we can see that we don't have any containers running right now. We have the images, but we don't have the containers that are running right now. So let's do the port binding, and let's also run it on our local host, right? So let's so for that we write the command docker docker run in detach mode, and then we use the command -p, right? This means to publish, right? So let's say I want to publish it to the 80 port 8080, and we will publish the, let's use this container, right? With the version 1 point, with the tag 1.25.5, right? So this is using by default the port 80, right? So this container was using the port 80 by default, it's using this one. So we will export it to our local host, right? So we, that's why we write, so this is the by default port and we want to use it at the local host port 8080, right? So that's why we write this command, and then we write the image name nginx and the command 1.25.5, and let's execute it. All right, so it's up and running, so we can access it now. We can, now the container is running, so let's first verify it, and then okay, so it's running, right? So okay, let's now check it on our local host if it's running or not. We can see that the nginx container is running on our local host at 8080 also now. So it can be seen over here also that our container is running at the localhost 8080. All right, so now let's see how we can stop the containers and start the containers. As we already know that we can stop the container using docker stop and the container id, but rather than using this we can also use the image name, right? So we can see that the image name is this, right? But this is assigned by default, right, when we created the container. So you can use this also to stop the running container. All right, so we execute this and the container would be stopped. So if we execute docker ps again, so you can see that no container is running right now, right? And to see, so by and to check how many containers we have available, we can execute the command docker psa. It will show you the list of containers that I have or we have. uh, so we see all these containers are stopped, all of them are down, they are not working. The containers that would be running would be visible under the command docker ps, but the containers that were created before and are stopped or whether they are executing would be displayed using the command docker ps dash a, right? So let's do something. Let's restart a container, right? So to restart a container we can write the command docker start and use the container id or the container name. So let's use the container id. Maybe okay, so docker start and the container id, so it will restart the container which is stopped, right? So we stopped a container, we are restarting it now. All right, so it printed the id, so that means it started again. So when we execute docker ps, so we can see that the container is up and running again. All right, so we have only one container up and running, but the name was assigned by default. So let's lastly understand how we can assign a name to the container by ourselves, right? The name that we want. So for that, so I will use the same image and create another container of it, right? So as you know that we can create multiple containers of the same image, so I will create another container of it. So for that we will write docker run dash dash name. So using this command we can create, we can assign a name to the container. So let's assign a name such as you can call it Mars app, let's say, right? So this is the name, Mars app, and then again we use the same other commands such as /d dash d for detach mode and dash d for publishing to it to the uh, let's say let's publish it to the port 9000, and the default port that nginx is using is 80, and then write the image name. So we are using the same image, so we will just let's just copy paste it, right, and press enter. So it will now create another container from the image that is now available locally, which is nginx with the tag 1.25.5, and which will have our default name Mars app. So let's confirm this, docker ps. So you can now see that we have two containers of the same image, but the names are not different. So this was the previous image, the previous container, and this is the new container with the name that we just assigned, Mars app. All right, so let's end this video, and if you like the video, so make sure you hit the like button and comment down if you have any questions. And in the next tutorial I will discuss about the docker file and docker compose. So make sure you are subscribed and you are following my channel. All right then guys, ciao.